Today we're going to be talking about the properties of logarithms. So we've got some learning targets to be able to use the change of base property to understand product, multiplying, quotient, dividing, and power properties, and to be able to use those properties to expand, condense, and simplify different logarithmic expressions. So to start, we have this concept of a change of base. Well, if you think about a logarithm has a base because we're asking ourselves what power, right? That question. So I can change, let's say instead of log base A, I decided I want to have log base B. Well, in order to make the switch from log base A of x, I can use log base B of x divided by log base B of A. So there's one form of the change of base. But then let's say that I decided I want to change log base A of x into a log base 10, or the common logarithm. I could do those two together. Or I could also say that log base A of x is the same thing as the natural log of x divided by the natural log of A. And so I'll get to kind of proving this once we get to some other properties. But for right now, what's important to help you remember the change of base is whatever is inside your logarithm is inside the numerator. And then whatever your base is, A, is going to be the value inside the logarithm that's in the basement. Basement. Math jokes, just a little way for you to remember it. So even if you change to a common log, we have the x in the numerator, we have the a in the basement, or the old base that we had. Realistically, I would encourage you to not memorize the change of base formula. I would encourage you to practice using it, but then eventually we'll get to a way that you can solve without really needing the change of base. So change the following to common log and then natural log. So common log is going to be that base 10. So log base 3 of x would be the same thing as log of x over log, remember the b is going to be in the basement. The natural log then is going to be the natural log of x over the natural log of 3. Common log for this one is going to be log of 4.7 divided by log of y. Again, that old base is now the object in the basement. Natural log of 4.7 over the natural log of y. Now, you might be asking yourself, why is this even necessary? And the reason why it's helpful is because your calculator does not have, well, some of them do, most of them don't, have the ability to type in things like log base 20 or log base 3 or log base 4. Instead, they have the log button, and they also have the natural log button. So if I wanted to evaluate log base 20 of 175, instead of having to go through my math features and then scrolling and finding this log base thing if my calculator happens to have it, instead, a shorter way is to use change of base. So I'm going to say log base 20 of 175 equals, we don't know, but I'm going to choose, for this one I'm going to use common log. It'll equal log of 175 divided by log of 20. So in my calculator, I can take the log of 175 divided by the log of 20. And we get 1.72. We need 3 decimal places, 724. Now, what's pretty cool about that is I could have picked a different log base. So for instance, if I had done the natural log of 175 divided by the natural log of 20, I get the same answer. And what that question is answering for us is 20 raised to what power gives us 175? Well, it makes sense that our answer is between 1 and 2, because 20 to the first is 20, and 20 to the second is 400. And 175 is somewhere in between 20 and 400. So use your calculator and go ahead and evaluate the next two using change of base, either with a common log base 10 or a natural log base e. All right, there are your answers. If you've got questions about those, make sure you check with your teacher, but those should really just be calculator kind of plug and chug type problems. All right, so more properties of logarithms. These are where we're going to connect that concept of a logarithm with the concept of an exponential. So the first property deals with product, because we have a multiplication on the inside of a logarithm, and we can use addition to separate those into two separate logs. So log base a of x times y can be split up into log a of x plus log a of y. And that is connected to our concept of exponentials. If I had a to the x times a to the y, that's going to be a to the x plus y. And so our multiplication gets kind of shortcutted or connected to addition. This one then we have division, so our quotient happening. We can connect our quotient, x over y, by splitting up with subtraction, log a of x minus log a of y. And that comes from our connection with exponents. When I'm dividing and I have the same base, I end up with a to the x minus y. Okay, again, same base going on here. That's going to be important. This last one is maybe a little bit harder to see, but I have log base a of x raised to a power. I can end up rewriting that using a multiplication problem. So something in the exponent can be rewritten using multiplication. And where we've seen that before is if I had a to the x raised to another power, that's the same thing as a to the n times x. So we're going to multiply. This one right here is going to be really, 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 really important. These other ones you're going to use often, but this right here is going to be important once we get to solving using logarithms, that we are allowed to turn this exponential problem into a multiplication problem. And that connection comes from thinking about repeated multiplication is the same thing as an exponential. All right, so expand the expression. Here we are starting with a product. So the natural log of x squared plus the natural log of y cubed. Then I have these exponents, which I can swing down in front using that power property of logarithms. So I'm going to get 2 natural log of x plus 2 natural log of y. This next one then, I'm starting with some division overall. So I'm going to do the log of the square root of x minus log of y. Notice that I'm starting with the common log here. I started with the natural log here, but it's all types of logs. This then I could rewrite as x to the 1/2 using my rational exponents. And now I can use that power property and swing that 1/2 down in front for my final answer. All right, condense the expression. I'm going to have you add into a single log. Well, if the directions say we're supposed to write it in a single log, that means I should only be writing the word log once. So I'm going to start to do some rearranging here using my properties. Looks like I've got this 3 kind of out in front, so I'm going to start by undoing that. And I'm going to have this be log of x plus 2 to the 3rd power, so this time I'm swinging it back up, plus log of x minus 5 minus log of x squared minus 3. All right, well, the next thing then, I've got some addition going on. So my 1/5 is just hanging out in front. Addition, I know, can be turned into, 2, can be turned into multiplication. So all of that is inside that logarithm. Minus log of x squared minus 3. Well, now I've got subtraction, and I know subtraction can be rewritten using division. So I'm getting closer. I have a single logarithm, and I still have this 1/5 hanging out in front. Well, because this is multiplied outside of the logarithm, I can move that up to my exponent, which means really this could be written as the log of the 5th root of x plus 2 to the 3rd power times x minus 5 over x squared minus 3. And that would be your most simplified answer. So again, thinking about our rational exponents, I am raising it to the 1st power and then taking a 5th root, because that root is underneath or in the denominator of your fraction. All right, rewrite the expressions in terms of natural log of 4 and natural log of 5. So we start with the natural log of 500, and we also have the natural log of 5 halves. my first challenge to you is to think about how to write the number 500 in terms of just 4s and 5s. Then I want you to think if you can figure out how to write the number 5 halves in terms of just 4 and 5. So go ahead and pause your video, see if you can think about a way to rewrite those. All right, so breaking down 500, this was the route that I took, which left me with 5 to the third times 4. So if I go back to my natural log of 500 and rewrite 500 as 5 to the third times 4, I can use my log properties. That multiplication is going to turn into addition. And then I can swing my power property. And now my final answer is in terms of just natural logs of 4 and natural log of 5. This one was a little trickier. The 5 just stayed as a 5, but then I rewrote 2. I had to have it in something with 4. Well, 2 is going to be the square root of 4. Now you might be asking, why didn't I think of using half of 4? And the reason for that is because I want to think about being able to use that power property. So if I had done half of 4, I would have ended up with 5 over 4 over 2, which really would have been 10 over 4. And there's no way I'm going to then break that down into just 4s and just 5s. So I wanted to use the square root instead. All right, this next one is a very similar concept, except now instead of using 4 and 5, you get to break up these numbers into 2, 3, and 5. So think about if you can rewrite the number 30 in terms of 2, 3s, and 5s. Think about if you can rewrite 16 and 25, or 16 25ths, in terms of 2s and 5s. So go ahead and pause your video and start with that part of it. All right, so hopefully the 30 went pretty well for you. 5 times 2 times 3. Which means I can break that up into addition problems. Log of 5 plus log base b of 2 plus log base b of 3. And then I can take log base b of 5 plus log base b of 2 plus log base b of 3, which in my calculator is going to be 1.7479. So then going back to this one, there's a couple ways you can think about this. Some of you might see 16 as 2 times 8, which then 8 is 4 and 2, which 4 is then 2 and 2. So 2 times 2 times 2 times 2. And then 25 is going to be 5 times 5. So we're rewriting again with 5, a 3, and a 2. Or we can think about that as 2 to the 4th and 5 to the 2nd. So we start here, in which case I can rewrite that as 4 log base b of 2 minus 2 log base b of 5. I changed the style of my 2's. Don't ask me why, it just happens. And again, using your calculator then, you should be able to get your decimal approximation. So let's look at that. And we end up with negative 0.2294 for our final solution. All right, so again, the trick there is rewriting using the information that you have numbers about, because we don't know what this base is. So we instead are going to use the decimals given and kind of rearrange and work the problem to be in our advantage. All right, so these last ones I want you to rewrite and simplify. These are just extra practice problems. So you want to think about breaking up to 43, maybe something with a base of 9 if you can. Then the natural log, we can use log properties for both of the next two that are happening. So go ahead and try these problems, see if you can rewrite them in a way that allows you to simplify a little bit. All right, so hopefully you tried these on your own and you're not just watching the video, letting it play through and writing down all of my work at the end. So I mentioned trying to rewrite things with a base of 9. So I broke up 243 to be 81 and 3. So then 81 is 9 squared, and 3 is the square root of 9, or 9 to the 1/2, which allows me to rearrange. And if you remember from our log definitions, log base 9 of 9 is equal to 1. And log base 9 of 9 is equal to 1, because you're saying 9 to what power gives me 9? Well, that's going to be 1. Likewise, natural log of e to what power gives me e? Those will cancel. Same thing there. So we can clean up a little bit, not completely, but those are going to be your most simplified answers. All right, there will be another video of just practice problems of these types that is optional for you to watch, but I strongly, strongly, strongly recommend that you do that to best prepare for your understanding of logs.